Hello, welcome back to New Scientist Weekly, the essential selection of the week's science stories. I'm Penny Sarche.
And I'm Rowan Hooper. Welcome to the show. Coming up on the show this week, we have an amazing story about what a 40,000-year-old horse bone, or maybe bison bone, is telling us about a vital time in human cultural evolution.
Very intriguing. We're also looking forward to the European Space Agency mission to Jupiter. And we have an astronomy report from the Atacama Desert in Chile. And from Brooklyn, we've also got a report on the construction of a quantum internet for New York City.
But we're going to start with a story about feeding the world population. Now, quite often when we write about environmental pressures and problems in New Scientist, people complain that there are too many people on the planet and that's the biggest problem we have. So I was interested to see a paper this week looking at the planet's feeding capacity, so the amount of people we could feed on the current agricultural land. Madeleine Cuff has reported this story for us. Maddie, what's the background here? How many people are we talking about?
Hiya. So at the moment, the current population of the world is about 8 billion people, and that's predicted to grow to reach around 11 billion by the end of the century. That's according to the UN, which is where it will probably peak, if not before. But that, stark increase in the number of people on the earth means that the question of how many people we could possibly feed is going to be pretty crucial in the coming decades.
So what has the new study found then?
So it finds that we could theoretically feed almost 20 billion people on the world's current agricultural land. And that's if everyone in the world also ate lots more plants and a lot less meat and dairy. That's the planet's maximum feeding capacity, if you like, using existing farmland. But there's a big but. It comes with pretty huge ecological risks because it would require vast amounts of industrial nitrogen fertilizer to achieve. And this would take the world way past its safe planetary boundary for nitrogen use. And it's worth remembering that too much nitrogen causes really big and horrible biodiversity impacts. So it's creating dead zones in rivers and oceans, and it also can accelerate climate change. So it's not something we want to be playing around with too much.
No, well, don't we already know that? Haven't we already blown past these planetary boundaries, the thresholds for nitrogen use?
Yeah, so that's the slightly worrying thing, is that the world actually passed its planetary boundary for nitrogen use back in the 1960s. So for decades, we've been using far too much nitrogen in farming. The lead author of this new study, a guy called Petros Chatsimpiros, says that actually this planetary boundary for nitrogen is a bit of a soft boundary. So the world doesn't come crashing down immediately if we blow past it. I mean, otherwise we would have known by now. But there is a risk that comes with doubling down and using even greater amounts of nitrogen in the future. It would be a pretty risky strategy because there could be unforeseen negative feedbacks from the amount of nitrogen pollution that we are causing from the overuse of fertilizers. So we just don't know whether by pumping too much nitrogen pollution out into the world to feed that many people, whether that will essentially crash our feeding capacity in the future. So we could be eating on borrowed time.
And making industrial nitrogen fertilizers, it's really carbon intensive as well, isn't it? So we know that overuse of these fertilizers, not a good thing. So how many people could the world feed with the agricultural land it currently has without taking quite so many risks with that industrial fertilizer use?
Yeah, so essentially, if we really dialed back the use of industrial fertilizers, the study authors say that probably the safest way to feed the world's growing population is probably a switch to organic farming. So organic food production, they calculate, could feed between 3 and 14 billion people using current agricultural land. That's obviously a huge range. And basically it depends, again, on how much meat and dairy people eat as part of their diet. But it would also require farming systems that are done organically to maximize their yield and prevent nitrogen leaching. So that's going to be really careful management of organic farming systems, making sure that you really make the best use of manure to feed soils and you rotate crops to include nitrogen fixing plants. So it's pretty hands-on approach to organic farming to make sure that you get as much bang for your buck as possible, really.
There's always such a debate about organic farming, isn't there? Whether it's the most efficient use of land and the role it would play in a sort of sustainable agricultural future. So I'm really intrigued that it is such a large range, 3 to 14 billion. So at the one end, that's mass famine, and on the other end, everything's solved and we're all fine.
Yeah, completely. And I mean, obviously, it goes probably without saying that shifting global agriculture to a system of organic farming would be massive and maybe even impossible as a transition to make. So, probably what's a more likely sustainable alternative is more organic farming, sure, but also more or judicious use of industrial fertilizers in sort of standard farming systems. But probably one of the key takeaways from this study is not just that we need to use nitrogen much more efficiently, but also that under all scenarios, how much meat and dairy people consume is really crucial. If everyone in the world consumed a Western diet, which is roughly 55% animal protein at the moment, we couldn't even feed 9 billion people on the planet. And that's even if plenty of fertilizer was used and we converted additional grassland, covering an area equivalent to Russia, into more agricultural land. So, how much meat and dairy we all eat is really central to this.
Wow, I don't think I knew that we ate 55% animal protein on average. That kind of seems like loads. So I guess this paper then is yet again showing with the various options and scenarios that, we really have to cut down on meat and dairy.
Yeah, essentially, the paper is basically saying that we can feed the world's growing population, but it could come with a cost. So
Of
reducing our
destroying the planet.
yeah,
Just that cost.
so reducing the consumption of meat and dairy is going to be essential. But even then, if populations reach upper estimates, then we also need to get better at managing our use of nitrogen fertilizers. Otherwise, we could just be storing up a food crisis for the future.
Next up, features editor Alison George is here with a story of how a bone, nearly 40,000 years old, is revealing how clothes were made in Stone Age times. Ali, what is this story?
Yeah, this is really amazing. I love it. It all started with the discovery in 2007 at a site near Barcelona of a bone that's almost 40,000 years old. It's probably the part of a hip of a horse or a bison. And it's just got a really strange pattern of notches that have been made on it.
Okay, quite intriguing, but how do you get from notches to, the making of leather clothes?
Yeah, this is a bit of a Stone Age whodunit. There were 28 puncture marks on the flat surface of this bone, including a very neat line of 10 holes about 5 millimetres apart from each other, as well as other holes in more random positions. So when archaeologists see deliberate patterns of notches on prehistoric objects, they're usually either an artistic decoration or some kind of counting tally.
Right.
But the patterns on this Spanish bone didn't seem to be either of these. So the archaeologists took a good look under the microscope to see if they could find any clues as to how and why the notches were made. And this revealed that the line of 10 indents was made with one tool, and the other dots were made at different times by 5 different tools. So they then used an approach called experimental archaeology. This is when people use lots of different types of ancient stone tools to try and recreate the marks that were found on this object. And they found that the only way to recreate the particular type of indents on this Spanish bone was to knock a chisel-like tool called I think it's called a berin, through an animal hide.
Right.
And this technique is called indirect percussion. And the same technique is still in use by some modern day cobblers and in traditional societies to make holes in leather. So the most likely explanation for the indents on the Spanish bone is that they were made during the manufacture or repair of leather items such as clothing or tents or bags.
Wow.
And after punching a hole in the animal hide, you could poke a thread through with a pointed tool to make a tight seam.
Because they didn't have a tool to poke through it on its own, you had to punch a hole through first.
Yeah. So needles didn't appear in this region until around 26,000 years ago, but humans arrived there 42,000 years ago. So you've got a big gap between the people living in Europe and the arrival of or invention of needles with an eye in them. And also, needles aren't strong enough to repeatedly puncture through thick leather. So this raised the question of how people were managing to make fitted garments without needles.
Wow. So all of this, we're getting it just from this bone. We've managed to piece together this whole missing part of human history. That's amazing, isn't it?
Yeah, and it's a really, really important part of human history too, because these people arrived in southern Europe around 40,000 years ago, and there were some really cold snaps then. So they really did need good clothing to help them survive.
Yeah.
So the ability to make fitted leather clothing is a massive turning point in human adaptation, cultural adaptation to climate change, and it helped modern humans expand to new regions. So it's a really big deal.
I wonder if we should go back and look at other artifacts now. You might expect this device to be something really valuable across these early human societies, right? So maybe other people had it.
Yeah, I mean, I imagine there are quite a few archaeologists sort of rattling around in the back of their drawers looking for objects with these weird patterns that couldn't be explained on them. So, yeah, this does seem like a really important toolkit. There's some really interesting evidence about clothing that comes from lice as well. Head lice and body lice, which live in clothes, diverged about 80,000 years ago or even further away in time. So that hints that humans were making clothes at least 80,000 years ago. We just didn't know how.
Wow.
Yeah, so obviously this discovery of this Spanish punch board is a pretty big deal. But it also, to me, gives us a really interesting snapshot of daily life in the Stone Age. It was only one of 6 artifacts found at the site, along with lots of animal bones. So it looks like it wasn't a permanent settlement and that the tool might have been accidentally lost. It could have been part of a repair kit that was carried around. We know it was used 6 different times, possibly to carry out repairs. And the neat line of notches shows that the person who made them was a really skilled artisan. So you've got this lovely snapshot of Stone Age life from this one tool.
Oh, that's an amazing discovery. Okay, thanks, Sally.
Time for a break and some messages. Tickets are now on sale for New Scientist Live.
After a triumphant return in 2022, New Scientist Live is back. It's on Saturday the 7th to the Sunday the 8th of October, and there's a dedicated schools day on the 9th of October.
Join us at XL London or online to hear thought-provoking talks and enjoy amazing interactive experiences brought to you by people shaping the world of science and technology. Find out more and book your early bird tickets at newscientist.com/NSpodcast.
Now that's the sci-fi alert. That's when we have a story that just sounds outrageously like something out of science fiction. And this week, it's the construction of a quantum internet in New York City. Carmela Padovich-Callahan joins us from New York. Carmela, this is your backyard.
Yeah, that's exactly right. So last week I went to an old shipyard in Brooklyn where there are now offices. I live in Brooklyn. And I saw a demonstration of an early precursor to what might one day be New York's quantum internet. I didn't know this coming in, but I learned that some of the fiber that this quantum communication startup called QNect is using actually does go through my neighborhood. So I probably walked above it as I was getting there.
So you basically feel like you're living in the future now, do you, Carmela?
I mean, if reporting on physics has taught me anything, is that the future is not now, but probably happened yesterday and we didn't know. So who knows? Who knows what's the next thing I'm going to learn, you know?
Okay, so let's take a step back. What is the quantum internet and why do people want to build one?
Yeah, so I think our listeners have heard us talk about quantum computers before, and quantum computers have this, grand promise of being able to solve problems that even the best supercomputers that we have today cannot. But if you think about how we use regular computers already, a lot of what we do is we connect them and let them exchange information in the regular internet. This is how I'm talking to you from New York right now. So it stands to reason that if we had quantum computers, which are that much more powerful, we would also want to connect them and have them exchange information. But because this is quantum physics, the quantum particles we would use to connect these quantum computers or connect any sort of quantum device, they have special properties which sort of have added benefits. And one of these added benefits is that a quantum internet would be virtually unhackable.
Okay, so how does that work? And why is there this quantum internet fiber running through your neighborhood?
Yeah, right. So the unhackable part really hinges on this quantum property that's called entanglement. So if you have two entangled particles of light, which are called photons, and you want to send them to some optical fiber to exchange information with a friend, if one of them got tampered with by a hacker, the other one would instantly change its properties. So you would, by looking at that other one, be able to tell that someone's hacking your conversation with your friend. And what this company that I went to see, Qnect, has done is they have built, or they didn't even build it. They just like used a 34-kilometer long loop of fiber that was already laid down in New York City, and they sent entangled photons through it. And basically, when I went to see it, they were like, "We've been running this experiment for 12 hours. It's working. Entanglement is preserved even underneath the city streets, and they can do it at tens of thousands, hundreds of thousands of photons every second."
What? So the communication isn't instantaneous, but you'd instantly know if something was going wrong.
Yeah, exactly. So you would always keep one of the photons in the lab for reference, and you would be monitoring that one. And you can imagine that there would be, a ping, and you would be like, aha, I'm being hacked right now
Right.
in real time.
Right.
And then you
Yeah.
could sort of protect yourself.
So how soon then do you think until you could have a Connect box in your home in Brooklyn?
Well, okay, so this is like very early days. They've only
Mm.
built a couple of these, and I think banks and universities are going to beat us to it. They are trying to put one of these entanglement sources at New York University, which is across the bridge from Brooklyn and Manhattan. So they would get more of the city connected. But I think it will be years before this is cheap or accessible technology. And you should also ask yourself, like, do I actually need the quantum internet? And the answer will probably be no for quite a while, unless you're about to get really into quantum physics for fun.
Now, as we speak, we're waiting for the April 13th launch of a European Space Agency mission to Jupiter's icy moons. Leah Crane joins us from Chicago. Leah, I know the spacecraft won't reach the Jupiter system for a while, but it's a really exciting mission, isn't it? Tell us a bit about it.
Yeah, so these are some of the best moons in the solar system, in my personal opinion. The mission is called JUICE, which is short for Jupiter Icy Moons Explorer. So it's exploring 3 of Jupiter's biggest moons, Ganymede, Callisto, and Europa. And all of them have these sort of icy surfaces, and they're all thought to have oceans beneath those icy surfaces, which is what makes them really particularly interesting.
Yeah. I saw a statement from ESA saying that JUICE is going to make these detailed observations of the moons, both as planetary objects and possible habitats. But they don't mean for us to live on, do they?
Absolutely not.
No.
They mean possible habitats for microbes, not for
Right.
humans. These would be truly deeply horrible places to live as a person.
Yeah, because that's why we're interested in those Jovian moons, isn't it? Is because they're so close to a massive planet. They get these huge tidal forces. So we get tides from our moon, but like the tide or the tidal forces on these moons are so much that it really warms up the core, and that's where energy might come from, right?
Yeah, so we think that because these moons are getting really stretched all the time by Jupiter's gravity, they have some heat in their cores, and that is part of what allows them to keep these liquid oceans, even though they're so far away from the sun. It's so cold over there. So they are possibly really good environments for life because they have these liquid oceans that might be at temperatures that are reasonable and that might have the sort of nutrients that microbes need.
This is one of those multi-generational science projects, isn't it, that goes on for so long with dozens of researchers around the world. And there's 10 scientific instruments on the spacecraft. There's a magnetometer and spectrometers. Have you got a favorite instrument it's carrying?
I do. It has a radar instrument that it's going to use to find the thickness of those ice shells and
Mm.
potentially also the depths of the oceans. And that's never been done, particularly on Europa before. And the depths of that ocean and how deep it is under the ice is really, really important, not only for the potential for life, but also for the potential for us to find
To
anything
get
out
there.
about those oceans.
Yeah.
Because they're underneath that ice, we can't really tell that much about them from afar or even from up close. But if the ice isn't too thick, we might eventually be able to send something to burrow into them and tell us
Mm.
about those oceans.
Yeah, and you mentioned Europa, and I was looking at the mission in it. So the spacecraft is going to make 2 passes by Europa, 12 by Callisto, but then it's just going to stay by Ganymede for the remainder of its time. So I'm slightly disappointed by that, to be honest. Why are we going to Ganymede for so long?
Yeah, I'll say when I looked at the mission specs, I was also a little bit disappointed that it was
Yeah.
so much Ganymeted because Europa is sort of canonically the
Yeah,
interesting one.
yeah.
Um, but Europa is also pretty small and close to Jupiter. So it's really hard to get into orbit around it. Whereas Ganymede is a little further away and absolutely huge. So going to Ganymede allows us to have a much better chance of mission success, a much better chance of actually getting into orbit and staying there for a long time.
Right.
And Ganymede is pretty interesting in its own right. It also has probably that liquid ocean, and it is the only moon in our solar system that seems to have an internally generated magnetic field from a liquid core.
Hmm.
So figuring out how that works and how it interacts with Jupiter's magnetic field could also be really, really interesting.
Okay, so we will give some love to Ganymede after all. Um, so we mentioned the 3, but there's 4 big moons of Jupiter, aren't there? There's Io as well. And by the way, I do recommend anyone trying to have a look for these because even with the naked eye, if it's in a dark place, you can see the 4 big moons of Jupiter, and certainly with binoculars, you can see them. But why aren't we going to Io?
Io is, in my opinion, one of the coolest moons in the solar system. It's got all kinds of volcanism. It's an absolutely wild place. It's also so close to Jupiter, and it is would be really dangerous for the spacecraft to get that close to Jupiter early in its
Right.
mission because of the radiation environment. There's just a lot of radiation there. So it's going to pass pretty far away from Io. It's going to take some pictures of it, but it's not going to get right up close. Also, it is the Icy Moons Explorer. Io's not particularly icy, but I think that decision sort of went in the opposite direction.
Great. Well, it is really exciting. Unfortunately, we've got to wait 8 years or something until it gets there. But we'll put
Yeah.
links to the mission in the show notes and we'll keep you up to speed with what happens.
Now, our colleague Abby Beall is in Chile and she's in the Atacama Desert on a new scientist discovery tour. It's an astronomer's paradise. I've very much been enjoying her Instagram posts, and she sent us this report.
I've been having a great time here stargazing in the southern hemisphere. It's been amazing seeing how different even the constellations I'm used to seeing at home are from here. You know, Orion is completely on his side, kind of facing down rather than to the side, and Taurus is right under the horizon when usually you can see the Pleiades, you know, really far overhead. They're just at the horizon. And even the moon is upside down, which takes some getting used to. But what's been really incredible is seeing the constellations that you can't ever see from the northern hemisphere. Alpha and Beta Centauri, the pointer stars that point towards the Southern Cross, using the Southern Cross to find south. And what's been my favourite thing, I think, is looking at the Milky Way. At home, you can see the Milky Way, but the very centre of the galaxy, the kind of central bulge of the Milky Way, which is in the constellation Sagittarius, that never really rises above the horizon. It does a bit in the very middle of summer in June. It kind of rises about 10 degrees above the horizon, but it's kind of tricky to see because the skies in June at home never really get that dark. we got up the other morning at 5 a.m. when the moon had set. There was no moonlight. Sagittarius and Scorpius were really far overhead. It was completely dark. We walked out to just a 10-minute walk away from where we were staying in San Pedro de Atacama, and we had the most incredible view of the Milky Way. Through my binoculars, I could see various different nebula, and you didn't even need to really let your eyes adjust to see the complete streak of the Milky Way across the sky. It was really something special. And then last night we had a really interesting evening. We drove a couple of hours. It actually took about 3.5 hours in the end, to an observatory called El Sos Observatory. It's operated by a company called OBSTech, and it's really interesting because it's not like any kind of observatory I've seen before. It's a mixture of professional research astronomers and then just interested amateur astronomers. People can pay to have their own telescopes placed up there to get the most of the dry, clear skies, and they can be operated from anywhere around the world. There's a team of people there who kind of look after everybody's telescopes and keep them running. And we were up there to watch the sunset, to learn about the observatory. But while we were there, I had a chat with a woman named Elke, who runs stargazing tours nearby in a valley called Hacienda Los Andes. She was telling me about what she does and also about the work she's doing to try to make her community a dark sky reserve.
Well, the Hacienda Los Andes is an outdoor lodge that has been installed like 22 years ago, basically for a horseback riding business, which has then changed when an avid astrophotographer, Daniel Verschatze, bought the Hacienda in 2012, and he installed a private observatory. And that is a very high-end and high-quality observatory that is dedicated to remote astrophotography, but also offers stargazing tours and has several platforms where people can bring their own equipment and then install on the platforms with power outlets. What I'm trying to do is get the whole valley of Rio Hurtado certified as a dark sky community. And that means the whole valley basically that stretches over 120 kilometers from close to Ovalle to the Cordillera Mountains, which are the pre-Andes basically. And that is very intense work, but it's also very, very rewarding. And it's a very good thing to do because we have very, very good and dark skies in this valley, and we want to protect that.
How long have you lived here?
Well, I don't dare say it. This is my 8th year.
And have you seen the skies change a lot in that time?
I've seen the weather getting more unstable. It used to be that from November through the end of March or mid-April, it used to be very, very stable with hardly any clouds around, or when then they would disappear towards nighttime, and that has changed. So the weather is not as stable, and we are seeing more clouds. Yeah.
And what's been your most memorable experience, if you can pick one, of stargazing from here?
That is difficult. That really is difficult because I've had many memorable moments. Some of them right here on this hill because it has a beautiful view towards the west where you can see the spectacular colors of the sunset, and if there are conjunctions between planets, for example, or planets meeting up with the moon, then you have like the perfect setting for that. But I can also recall one or the other observing session at the observatory where I work with just spectacular views of Saturn and Jupiter in our telescope. And what is very memorable for me and very, a lot of fun for me as well is if I have groups there or people for a stargazing tour, and I can basically show them these highlights. Yeah, and they don't know what to say because they are so fascinated, yeah, by what they are seeing. You know, that's basically the best thing that can happen.
That was Abby Beall reporting from Chile, and she was talking there to Elke Schulz, who's trying to get her valley recognised as a dark sky sanctuary.
That's all for this week. Thanks to our guests Carmela Padovich-Callahan, Leah Crane, Alison George and Madeline Cuff, and thanks to you for listening. This is my last show as a podcast co-host for a while. I'll be heading off on maternity leave soon, but I'm looking forward to tuning in every week as a listener.
Thank you, Penny. And do subscribe to our show and tell all your friends about it. We'll see you soon. Bye for now.
Bye.
Bye.
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.